So, hello everybody. This is now the second opening of the EU PVSEC, and I am very glad to open the industry forum. I'm together with people from very international companies, which I will then introduce later on. My name is Radovan Kopeček. I am one of the co-founders of ISC Konstanz and director of ISC Konstanz. And here I am in my role representing EUREC, which has the goal to connect R&D institutes in the area of renewables. And the topic of today's industry forum is local production with international R&D, or as I would say, PV's coming home, and how can we all together make it sustainable. So I would say that the time is over where in Germany, German companies were producing like SolarWorld, Bosch and Sunways like a couple of years ago. So now it's time for local production with international cooperation. And there is a big spotlight from the European Union on NL, Meyer Burger, Oxford PV, but there are also other companies that are already producing or have ambitious plans to start production in Europe, like Valoesel, ICO, Carlion, and Norsan, but also Ecosolifer, and there are huge announcements of REC coming back to produce 5 giga in future, and also Greenland wants to set up a 5 gigawatt vertical integrated production in Spain. But let me introduce the topic today in basically 3 facts. So we all know that photovoltaic is the king of energy markets, and we are reaching levelized cost of electricity down to 1 cent per kilowatt hours. So this is what everybody knows. Maybe something that not everybody knows is that the economics and of photovoltaics is now completely different, like not like 10 years ago or even 3 years ago, where there was lower demand that people were able to produce. Now it's completely different. The demand is huge, but there are bottlenecks in production. At the moment, it's the bottleneck in polysilicon, but I believe in future it will be also bottlenecks in solar cell production and module production. So more or less, it's a no-brainer that we have to install capacity, local capacity worldwide. And let's put it this way, we have to assist China to produce locally, also to help the world with the energy transition, because we have ambitious plans. So local production is needed. And this is what we will discuss today, how we can all succeed to make local production in Europe sustainable. And please put your questions into Q&A, and at the end of the session, we will also try to answer all questions. But first, let me introduce our panelists, and then they will start with a 5-minute presentation of their project and then their future plans later on. But very quick introduction. We have Christian Peter. He is the head of Solar Lab ICO Europe in Germany. Then we have Tuukka Savisalo. He is the CTO of Valoe in Finland, now producing in Lithuania. Then we have Firat S. He is a research and development manager at Carlion in Turkey. And last but not least, we have Carsten Rohr, Vice President of Business Development at Norsan. They are producing wafers, and we will need many more wafers that Norsan can produce these days. So we will hear about expansion plans from Carsten later on. So, as I said, we start with a 5 minutes presentation of each company, and then we dive directly into questions from my side and then from the audience. So please, Christian, can you take the first presentation on ICO and what you plan to do in Europe as well?
Hey, hi Rado. Thanks for introducing. Bonjour de la Côte d'Azur. So I am happy to introduce quickly the plans of Solar Lab ICO Europe. So Solar Lab ICO Europe was founded with an investment of ICO Solar in China. And ICO Solar is one of the biggest PERC cell producers worldwide. The capacity right now is approximately 36 gigawatt, purely PERC and purely cells, no modules. So ICO Solar is, from my perspective and knowledge, the only Chinese tier 1 cell manufacturer who mainly uses European equipment. So I, for myself, worked approximately 13 years with Rena. And so I know exactly what is in their factory. So they have the Pacini or applied materials printers, centrotherm furnaces, and stuff from Heraeus, Jonas Redmann, and many other European suppliers else. And they also have invested a lot in our European manufacturing companies. So that's why they are, let's say, a little bit European affine, and they invested in Freiburg, in this company which I founded, Solar Lab ICO Europe. They also invested in EU, in the Zhejiang province. This is approximately 300 kilometers southwest from Shanghai. And this is an R&D center which is open for international cooperation partners like Rena, like Centrotherm, like Heraeus, and also international universities and institutes like TNO or ISFH, Fraunhofer, etc., etc. So why is ICO interested in, and why is ICO investing in this R&D partnership? And it's also EUREC, which I would like to announce here. So because ICO wants to earn money, and ICO sees that there is an increasing market in Europe, and ICO has the knowledge of mass production, but we see that there are a lot of institutes and good knowledge in Europe, and for us it makes absolutely sense also to produce in Europe. So on the left picture here, you see this European Green Deal, and on the right side, you see this perspective from Solar World Europe, the latest report. And for ICO, we see the market growing for 40 gigawatt installation, let's say in 2024 or 2025. We want to secure the supply chain for our European customers. ICO is supplying to most of the well-known European module manufacturers. I think right now there are more than 40 here in Europe at the moment with small capacities. And ICO is serving, I don't know exactly, but more than 50% of them. And with these increased R&D efforts, we hope that we can bring the most cost-effective technology here. And let's say our main shareholder and CEO, Chairman Chen, he predicted the ICO law. So we're laughing sometimes, but I think it's great. So we need 10% higher energy output and 10% less costs every 3 years. In the past, we succeeded for this, and we have to work hard for sure for the future to have this. For sure, as I mentioned, we are a company, so we want to earn money. So it's not only to fight the climate change, but also to earn money. But I think that's a good chance here. With the green energy, we can do both. We can do something very good for the world, for the future of our kids, and we can also earn money. So bringing together economy and economics and ecology is really a great thing. So Solar Lab for itself was founded last year. So this year we are doing technology evaluation with different institutes. And our plan is to have the factory start up in 2022 and have mass production 2023. So we are doing something very innovative, I think. We are just copying the Chinese. So doing the vice versa, maybe they did in the past, but I think copying in China is something, an honor for the party which is copied. So I don't want to give technology away, but I would like to have the knowledge of mass production from China and bring it back to Europe. So the technology evaluation we are doing right now, the scenario is that we want to establish a mass production site with 5 gigawatt per year. And we are still an OEM manufacturer. This means we are delivering the cells. So PERC for sure is the working horse, but now it's maybe at the cutting edge of its efficiency, and maybe in mass production it can achieve 23.5. But this maybe is a technology from today or yesterday, and the coming technologies maybe heterojunction, TOPCon, IBC, and later on perovskite. Heterojunction for us is let's say most straightforward, but it has its issues with all the money and the plating stuff. TOPCon, for us, it's most similar to PERC, so this could be favorable for a company like ICO. And IBC is still maybe the best for efficiency, but there are some uncertainties about production costs. Perovskite, I already mentioned, is something we're looking for. My background is also with the dye-sensitized solar cells, if someone can remember this. And I think perovskite can be the future afterwards. So for us, Europe is a very diversified market in respect to module manufacturing, and we want to serve this market with the best and most cost-effective cells ever. So thanks, Rado. That's it from my side. Now I'm open to questions.
Thank you very much, Christian. The questions will come later. First of all, and I guess there are many questions, so I have many questions, the audience even more. So be prepared for questions. But now we would like to turn to our second speaker, Tuka Savisalo from Valois, and his company is different. So they are, let's say, not the largest solar cell producers yet, but they are already producing in Europe, and they specialized on IBC technology. So they are the only IBC producers in Europe at the moment. I guess they have also a different business plan than you do. So maybe Tuka, can you present your business?
Thank you, Rado. I will tell a few words about Valois and what we are doing and what we aim to do in the near future. We are a Finnish technology company, and we specialize in photovoltaics, as you probably all here do. We are a listed company. We are listed in Helsinki Nasdaq Stock Exchange with headquarters in Mikkeli, Finland. And we have a module factory and R&D center in Juva, Finland. And we have cell manufacturing in Vilnius, Lithuania. We believe in back contact technology. So we think that there is a lot of advantages in having the contacts only in the rear of the cell. We believe that with this approach, we can utilize this same approach as electronics manufacturing and get a lot of benefits there. We believe that the back contact gives us better efficiency, versatility in different forms, flexibility in automation and manufacturability. Of course, if you go for IBC, you have the best visual appearance with nothing on the front side. And we have also figured out that with the back contact technology, you can achieve resilience and damage tolerance better than traditional methods. As I stated, our cell production is in Vilnius. We have a small pilot size cell plant with an annual capacity of about 60 megawatts. Currently, we are planning to increase to about 120 megawatts next year. We have modernized the existing facilities to produce the N-type IBC cell that was originally designed by ISC Constance. And we plan to continue our developing work together with the leading European institutes and leading companies. What we currently focus is product integrated PV. And there, the PV is not an independent product, but it's part of a different product. And it often enhances the overall product and can have a different, completely different requirements as a traditional one. But what we know so far is that product integrated PV vehicles is one very interesting market, and emphasis is really quite heavily on looks, power density, weight, and survivability and resilience of the system. We are different from most companies because we always consider the manufacturing very early on in the project. We can do any manufacturing setup that customer wants, and we think this is very important because in the designing stage you normally introduce most of the cost. We know that integrating a PV into products is there's still a lot of way to go before you can see it everywhere, but we do believe that that you will start seeing that very common in most products because of the cost and the development stage of photovoltaics. That is very mature technology already, and can extend battery life. There are a lot of challenges still, mainly leading to visual appearance. Visual appearance is not the key aspect when we are talking about the power plant and field. With the consumer products, the visual appearance is way more challenging with a different kind of edge quality, 3D shapes, and manufacturing integration is something that we are still working on. How we see ourselves in the future. We believe that we will soon have a world-class cell with over 25% demonstrated efficiency. We want to be a proven technology provider for biggest manufacturers, biggest names in the industry, like the big automotive companies or their supply chain. We believe that we will be the best technology partner for new innovations and materials. Our business model is not to try to invent everything. We want to collect the best innovation. We want to bring those into the market, and we want to be the number one go-to when somebody has a good new innovation. And together with the innovator, we want to bring those into the market. And this is my presentation for today. I will happily answer questions when it's time. Thank you.
Yes, so thank you very much, Tuukka, for showing us your technologies and your visions. We will have a discussion later on, but now let me turn to our next presenter. Firat is from Kalion, and Kalion something in between. They are not the largest producers, but I would say they are the largest vertical integrated company close to European Union. They have about 1 giga wafer cells and modules, even ingot. And so, Firat, please explain us what you are doing at the moment and what are your future plans.
Thank you, Radovan, for your introduction. Welcome to my presentation. I will give some information about our integrated photovoltaic production line. So as I said, we are Kalion PV Solar Technologies Factory. We are located in Ankara, the capital of Turkey. We were funded with an investment of $475 million, and we are having a 100,000 meters square integrated factory in Ankara, where we are doing our integrated production of PV modules. Since we are covering all the production steps, starting from polysilicon up to modules, our locality ratio is more than 75%, and our production capacity for modules is 1.2 gigawatts, and we are having 2.1 thousand personnel working in our factory, and we have a built-in 2.5 thousand meters square R&D center, which is located on the same roof. As I said, we have 4 factories under one roof, so we are fully integrated factory. We are growing our ingots, then we are producing our wafers, our cells and modules under the same roof, and you can see a photo of our first ingots dating back to last year. So now we are producing it. Here are some small facts about our products. So in our ingot factory, we are growing monocrystalline Czochralski grown ingots. We are using boron, gallium, or co-doped ingots with P-type, but for special purposes, we can also grow N-type ingots. And in our wafer factory, we are using diamond wire sewing, and now our present technology is G1 size, but in late 2021, we will be also having the second phase of our production to M10, which has now started, and now it's ramping up, and our wafer thickness is on 175 microns. And in our cell factory, we are using monoPERC technology. We are having bifacial solar cells for G1, and for M10, we will be starting complete in October 2021. And our efficiency is 22.3% in average, and we have 70% bifaciality for our bifacial solar cells. And in our module factory, we already started the M10 production, so we are having glass frameless bifacial modules for G1 size, which has around 410 watts, and we have glass framed bifacial modules with half-cut cells of 520 watts in our module factory, which have more than 70% bifaciality, same as solar cell production. And this is our integrated factory capacity. You can see our ingot is around 745. When it's completed, now it's 500 megawatts net, and wafer is around 750 again. And for cell production, we will be reaching 1.2 gigawatts in the end of October. Now we are around 500 megawatts for G1. And module, we are already around 1.1 gigawatts. Half of it is G1 size, and half of it is M10 size. And we are also having a R&D center where we are having around 2.5 thousand meter office and laboratory area, and 500,000 meters square open test area. We are running around 42 local, international, and national projects where we are trying to develop new technologies and decrease the cost of our products. And for now, we are producing 500 megawatts of G1 production for our Kalyon Karapınar solar power plant, which is located in the desert area of Turkey, which is in the middle of Turkey again, where we have around 20 million meters squares of area, and there we will be producing 1.3 gigawatt DC installed power solar power plant. And the main idea behind this project was the modules shall be manufactured in Turkey, starting from the raw material. This was the condition put by the government. So that's the main spirit of this factory. We are starting from polysilicon up to module, and we are sending them to our own power plant. And this is the latest photo of our power plant in Karapınar. Up to now, we had around 400 megawatts of modules installed and running right now, and it will reach to 1.3 gigawatts in the end of 2022, hopefully. And in our power plant, we are using single-axis tracking system with bifacial technology, and we are having centralized inverters for our energy conversion from DC to AC. So mainly that's about our factory, and thank you for listening to my presentation. In case of questions, you are welcome.
Thank you, Firat, for this very inspiring presentation. So same here. The questions will be following after our last presentation from Carsten Rohr. So everybody needs wafers, and as I told you before, polysilicon is at the moment the major bottleneck in PV, and of course wafers as well, because I mean we have a lot of capacities in China, but we need polysilicon for wafer production at the moment, and there will be wafers needed in Europe. Everybody will need it, like Meyer Burger needs it already now, and Valo SL, maybe Kalion, not so much because you have your own production. If you are not vertically integrated and you start production of solar cells, you need wafers. So Carsten, can you please tell us your plans, how you can supply the whole solar cell producers in Europe?
Yes, thanks for the invitation. It's great to be able to speak here. I'll tell you a little bit about Nursun and our plans for sustainable production of premium ingots and wafers. We are the leading ingot and wafer manufacturer in Europe, as Rado was mentioning. We are placed in this part of the value chain. We do ingot and wafers, and that's the only thing we do. So we get polysilicon and sell the wafers to cell and module producers. We have been doing that for some time, since 2007 when we started. And we have been supplying for all this time to the tier 1 top-end solar cell manufacturers with the highest efficiencies in the market. More recently, we have also put more focus onto our CO2 footprint, which we have based on the hydropower and natural cooling water. And you can see that in the picture where we located with our manufacturing plant in Årdal, that is at the end of the longest fjord in Norway, the Sogni Fjord. And there the plant is located, and on the other side, so to say, there's a freshwater lake where we get our cooling water from, which is essentially generated from the mountains around, which are over 1,000 meters high, and a glacier, Europe's biggest glacier nearby. And of course, the hydropower availability there, which provides low cost and clean electricity. So that is essentially giving us a unique position in the fastest growing market segments. As I mentioned, we have specialized from the beginning in high efficiency, N-type material in particular, and as the ITRPV roadmap shows, this is expected to increase, gain market share considerably over the next few years. And it's, of course, the basis for next generation PV technologies, TOPCon, heterojunction, IBC, etc. So that is one of the main competitive advantages. That's where we come from. That's what we're good at. We are the only significant non-Asian wafer players, and that's also one important part that we can play in is re-establishing local manufacturing sites, both in Europe. That's of course the main focus here, but there are similar considerations in the US and other parts of the world. And the other element that's related to that is also that we have full traceability for our materials, and there's no exposure to forced labor, which is increasing a topic in discussion in particular with Xinjiang province in China. I mentioned it already, a uniquely low CO2 footprint that we have. We have certified that in various markets. For the French market, that's of course a long-established CO2 market, which explicitly values low CO2 footprint, and we've been active there. And that's not just N-type material, that's also P-type, P-PERC, etc. The Korean market, CO2, more or less modeled on the French, came now in last year. Also a big market, and we see and help develop environmental footprint markets and low carbon footprint markets. And that's we've been initiating, for example, the environmental product declaration, product category rules that were established, and so that it is possible to certify the environmental footprint, for example, for construction projects and other projects. So that's an important part, and we expect those markets to continue to grow. That's also why we are active and have been a founding member of the Ultra Low Carbon Solar Alliance, and also a founding member of the European Solar Manufacturing Council, where I'm also a vice chairman. So what we are currently doing is we are in what we call our phase 1 expansion. We have installed large pullers, of course much larger than the ones that we installed back in 2007, now 28-inch plus size. And then that's to grow to about 1 gigawatt capacity, and obviously by increasing productivity, throughput, reducing cost, and also by more automation. And the other important aspect, in particular with crystal pulling, is safety. And this is potentially a dangerous business because there's extremely hot temperatures involved in melting silicon, more than 1,400 degrees. And at the same time, you want to cool the crystal as quickly as possible. So you need to be very close to that. And cold water and hot temperature is a bad combination that can lead to explosions. And we see that happening again and again with fatal accidents actually in China. That we can't afford to do in the West, so to say. And we have our own innovation in terms of safety features to prevent that kind of accident happening. So that's an important part of innovation for us. Then that's the next steps in the value chain is processing the ingots into blocks in a highly automated shaping center, then going through high capacity wafer source, and at the end through a high capacity wafer line to clean and pack the wafers. So that's the first phase that we're currently ramping. And then we are, of course, planning the next phase to serve some of the demand, at least in Europe and elsewhere. We are looking into what we call phase 2 expansion to 4 to 5 gigawatt, or potentially more. That is under consideration. Obviously, we need to grow with our customers, with the markets. We have access to land in order. Here the picture shows the land accessible directly adjacent to our existing plant, but there's also other sites in order that we could use and potentially have space for up to 10-11 gigawatts. So that's all part of the consideration under the pre-project that we plan to finalize at the end of this year, and then the project can start next year and essentially complete to start the ramp in probably the second half of 2023. And the technology that we're using and the innovation that goes into this, I already described to some degree, with highest ingot productivity, high material quality, and safe operation. of course, processing those ingots into wafers with the latest diamond wire technology, and a high degree of automation is crucial, in particular for us producing in Norway, which is, of course, a high labor cost country. So just to summarize, the competitive advantages for us is top quality, clean products, both in terms of environmental footprint as well as social standards, and being part of the Western European value chain. Happy to answer any questions and be part of the panel discussion.
Thank you very much, Carsten, for your technology, for explaining your technology and your expansion plans. So now I would like all panelists to join. And yeah, maybe I can start directly with Carsten, and we will have now 40 minutes of questions moderated by, and then we turn back to the audience. So Carsten, do you think your product will be competitive in costs with Longi? That means, will you be able also, let's say, to sell wafers to Christian, to ICO? Or will that be the case that you rather serve like niche markets like Valoe Cell, SunPower, and all these others? But I mean, niche markets are getting bigger. But what will be your business plan? Do you think that your wafers will be also found in utility scale in the future?
Yeah, obviously we would like to build on our strengths, and I explained what they are, both in terms of quality, carbon footprint, and value chains in local value chains in Europe. And that's clearly something that we want to build on, and as much as possible. So in our expansion, we would of course serve those markets primarily. And as you rightly say, these are the markets that are expanding fastest. So we expect that there's plenty of market demand in that segment, in those segments that we can serve and that we want to serve, and that we are best placed to serve. So demand is certainly not a problem as far as we can see it currently, and that's obviously also a reason why we're planning to expand.
Mm-hmm. Thank you very much. And so what's special about this session is also that we have many PERC producers here, because when we talk about renaissance of PV in Europe, we mainly talk about heterojunction and then future coming to tandem solar cells. So is it really possible to produce PERC cells and modules sustainably in Europe, Christian? And will there be also a possibility for companies like Greenland to produce sustainably, or what is needed that PERC production will also, let's say, survive the competition with Chinese manufacturers?
So for sure, I only can give my personal opinion on this, but I think we are not seeing the final production status for PERC. There is still room to improve. Let's see, with a lot of silver, you maybe can exchange the silver on the front side by plated silver or plated copper in solutions. You can even increase the efficiency to an, let's say, an average efficiency of 23.5, which is not seen by today. And also the automation status is quite high. So from our calculation, it's also possible to produce these PERC cells in Europe for on a very cost sensitive level and still very competitive. For sure, all these carbon compensation tax issues will play a role, and you have also, I think what Carsten mentioned, this forced labor stuff. So when I talk to the European module manufacturer, they would be happy if they could purchase, let's say, the same level of quality for the same price from Europe. So maybe it's even possible to get, let's say, 1 cent more per kilowatt, because for sure many of these modules are not going to the utility market right now, but the on-roof market, and on the on-roof market the price is not as sensitive as in the utility scale market.
Thank you very much. And so these are news that the Chinese manufacturer would like to produce in Europe. Do you see any others that have such plans, or like Longi, Jinko, or is this, let's say, a special?
No, I think from ICO, I have a real insight. From Jinko, we know that they planned it in the past. You remember that they wanted also to produce in the US. Longi for sure is also always looking where the market is. I think these companies are clever enough to see where the increasing market. And as I said before, everyone tries to earn money and fight for his market shares. So I'm pretty sure that they're also thinking about it.
Okay, and you plan in Europe to stay also a solar cell producer, or would that be interesting for you in future also to go into module production, or you will supply cells?
That's a good question. That's really a market strategy. Right now, for me personally, I would say let's remain in this field of cell producers, because on the other hand, you would compete with your own customers, which is always a question. Then you should make it really very, very big. So my personal thinking on this is just stay on these shoes where you know they fitting best, and serve your customers as good as possible. Maybe if one customer needs money and you have the chance to come to get a finger on the Chinese money printing sites, then you can also bring some Chinese money to Europe and invest in some of these module manufacturers. But in the end, let's stay a cell manufacturer first.
Okay, thank you very much. Now questions to TUCA. Are such companies like ICO competitors for you, or because you are following a completely different business plan? Are there maybe also possible collaboration partners, let's say, to stimulate the supply chain in Europe? How do you see the situation?
We feel that all activities in Europe are good. We do not see these companies, gentlemen here in this meeting, as competitors. They might be our suppliers. They might be our research partners in the future. We are really focusing on different route, and we want to push the IBC technology to its limits. Want to really work together with different partners, research institutes, and so on, to push the IBC technology to be not just the most efficient, but also very cost efficient. We don't intend to be a gigawatt player in this field, but we want to be in developing the technology that can help Europe obtain a really good market share in the global market as well.
And how do you see the movement now towards larger wafers, like to M10, M12? There will be hardly any, let's say, G1 in future, or maybe you can make an advantage from this disadvantage, because many companies like that are building shingles on the market just need smaller wafers, and hopefully Carsten will be also able to supply G1 in future. Can you a little bit elaborate on this G1, M10, M12 thing?
Yes. We currently are focusing on the G1. We don't see the big benefit in the bigger wafers because we are not competing for the last cents in the market or fraction of a cent. The integrated PV customer often requires a different size cell. We rarely do full cell, so we go half cell, quarter cell, or even smaller. If you have a bigger cell, you have to cut even more. So we don't really have any benefits in going bigger. And we have infrastructure that can do G1 very efficiently. It's quite cost effective from a point of view of having new machines and so on, because they exist as well in G1 size. We do believe that if you want to go to a gigawatt scale and want to compete for the big market power plants, and especially the bigger, the more important it is. But we don't see any benefit in going bigger. Only the material supply is the question. If Karsten can supply us high quality wafers with a market pricing, we don't really see a need to go for a bigger wafer.
Yes, we can ask him directly, Karsten.
G1 as a size is of course not a problem. We currently producing wafers in different sizes, everything from 5-inch, the old format, to M6 with the current equipment, which is limited to M6 for now. But of course, with the further expansion, we will of course have capability for M10 and G12 as well. But we do have capability for the smaller sizes.
Exactly, and I think if in worst case we would have to cut larger ingots to smaller wafers, if this, let's say, it's economically still okay for IBCs, but I think yes, G1 you will still have in your portfolio. The other thing is, let's say, the doping, and for IBC cells, at least for Zebra, we need higher resistivities, and this will, let's say, not be mainstream as low resistivities for PERC, and TOPCon need also low resistivities. Will that be an issue that special companies that are producing IBC need higher resistivities?
No, that's not a problem at all. We've had experience with that since the beginning of our existence, so that's no problem.
Okay. So I turn now to Firat and would like to know if at the moment, as I understood, your modules are based on G1. Maybe in future you go to M10 and M12. But my question would be, are you also, let's say, willing to cooperate with companies in future and maybe selling wafers, selling cells, or do you plan to implement all your products into PV power plants in Turkey, or will there be in future a different business plan?
In fact, for now, our production capacity for G1 is 500 megawatts, and this is solely working on our Karakular power plant. Of course, in 2 years, the power plant will be finished, and now in our module line, we already started M10 production with 500 megawatt capacity. So these products will be directly open to market. So we are planning to sell them to European, USA, and also its customers. For modules, this is basically that, and also for cells, we are also planning to sell solar cells, solar cells. For G1, as I said, it will wait 2 years, but for M10, they will be ready in the end of October. But for wafers, and I can say it will depend on the market, because mainly we will be using our own wafers, and we are short in wafers, even though we have some place for capacity increase in our ingot line. mainly our bottleneck is ingot and wafer production. So for now, we're using our own wafers. In the future, if market is okay and if it's more feasible, yes, we can consider to sell wafers also.
Thank you. And can you elaborate a little bit on your strategy for future production? So will you try, as Christian was explaining, are you going with PERC to the limits, maybe also go to 23.5% using plating technologies, or do you have on your roadmap also to go to N-type? And did you already, let's say, make any tries with N-type, if you can disclose?
Yeah, of course. In fact, we are still in evaluation stage because it's been 1 year since our foundation, and we are in the learning and also evaluation stage. So we are doing different trials for N-type IBC, as in ISC, and also with Valoe, we are having some trials with our own type of. But also we are interested in P-TOPCon and N-TOPCon. This seems to be closer for PERC production. Mainly, I think we'll go for PERC for some more time, and then depending on our strategy, which we will develop in a couple of years by our projects, we can see whether we will go N-type, IBC TOPCon, or P-type TOPCon.
Okay, and thank you. And how important is the vertical integration for you? So do you see it's a key for success, or do you think it's also possible for solar cell manufacturers go only for cell production?
In fact, I can talk for ourselves. I can see that since we are starting from silicon, we are never having some shortage of wafers or cells for production. This is really an advantage, and we have the full control on the process, on wafer resistivity, these kind of things are main advantage of production facility, vertical integration. But of course, if the number of producers in Europe increase, then be a big problem. Independent of east part, we can find which product we want the input to our production.
Okay, thank you very much. And Christian, you already touched this topic that that PERC is the working horse, and maybe we can go higher to 23.5% in future, and that you evaluated also TOPCon. Will it be difficult to go to TOPCon technology, or is it very similar to PERC production, as people are saying in your perspective?
From my perspective, it's similar. So you could maybe even retrofit some of the factories for which are now PERC to TOPCon. For sure, it has to be proven that all the efficiency goals really can be reached, and that also the cost level can be reached. But let's say at the moment we are checking the principle, and in principle, yes, it's possible.
Okay, thank you. Tuka, what kind of support you are missing from Europe? Is it more the financial support, or is it, let's say, a support on getting modules on the market, or how difficult is it to start cell production in Europe in your perspective, or what do you think is the major bottleneck?
The major bottleneck, of course, is the capital. It's still very difficult to obtain capital for investments in PV in Europe. A lot of people burned their hands in the previous let's say, surge in PV in Europe, and still it has not been established that PV is, let's say, investment worthy in Europe. I certainly hope that there will be more public initiatives or similar ways of obtaining public funds as in China. But yes, it is. There is a lot of new technology. There is no inherent reason why PV wouldn't be manufactured in Europe. It's just a matter of finding the investment money.
Mm-hmm. Carsten, from a technological point of view, yes.
Yeah, I agree. I think that's one of the main hurdles is the investment in expanding capacity, and that's and then we clearly see that, and I think we heard quite a bit of that in this morning's session as well, that politicians need to realize that PV is a strategic industry, and that we need to get away from being totally reliant on other parts of the world, and that we need to become more self-sufficient. So that's part of that, and other parts of the world realize that too. In the US, for example, also in India, similarly, there are incentives being put in place now for manufacturing. So the Manufacturing Act in the US, which is going through legislation, which would potentially give a huge incentive for putting up manufacturing locally in the US. I think similarly, that needs to be realized and incentivized in Europe too. And we have discussed some of these points. Obviously, as part of the European Solar Manufacturing Council, we are pushing for that. One element is also the environmental footprint, building on the strength that we have in Europe, and the carbon footprint in particular. There are some very good examples, like in France, where that is a big element, a big portion of their auction system there, and public support, and that could happen in other countries too. And then we have the eco design that's in preparation. That although it does take a lot of time to be implemented, it would strengthen the environmental footprint if it's implemented as a strong policy with strong requirements.
Mm-hmm. Thank you. And now I have a question to all of you. Of course, finances are extremely important to get started, but of course, at least from my perspective, the more difficult thing is, let's say, to stay on the market. And my question here would be, how can a no-name company which is entering the market, like Carleon, of course, you are a new player on the market, but we have, let's say, your own market at the moment, but how can Greenland survive? Do they need also their own market? Will they install gigawatts of capacities that they are producing themselves, or is there let's say a shortcut to bankability, call it this way, or will we need in future more Chinese players because they are already longer out there for setting up large gigawatt scale like ICO is planning at the moment? Yes, so the question, whoever wants to answer, how can... Yeah.
So maybe, Rado, I can start, and what I also know from my past, we should in Europe not only focus for subsidies for production, but we should also subsidize the end market. And let's say this Greenland example I like a lot. So I like the idea to bring employment to some of the regions where the unemployment rate is very high and have a very good product there. So I think from the state of the art, this product should be competitive. And maybe if you would use Chinese production know-how, which doesn't mean that you need production machinery, this can be done from everywhere. This could be something which is really reliable and in the market, but you also should strengthen the end market. And if there is some carbon footprint tax or some other protection, this is also neat, because I fully agree with Carsten. Europe has to understand that this is a strategic market. And for a strategic market, you not only have to finance the beginning, you also have to finance the end.
Okay, understood. Are there any other opinions on this topic, or is it? I mean, for Valoe Cell, it's a little bit different because you are, let's say, going a different way, serving the VIPV market first.
Yes, for residential market, the module price is now only a fraction of the overall cost, and there a lot of different ways can be done in order to get this get market share. And in Europe, the residential market is quite large. I don't actually know how big it is, but I think it's several gigawatts. The power plants is a really cost market, cost-focused market, and that is probably the most difficult. On the other hand, it is with a single power plant you can get work for 2 years or 3 years and that is easy to subsidize from a, let's say, government point of view. It's one single payment in contrast to thousands of households. But clearly we should find ways that distribute this benefit to everybody, starting from the households, or residential market or commercial market. I don't have an answer for this, but in these markets you don't have to find for the last single cent or fraction of a cent. If you're able to produce, make a brand yourself and have a product matching your brand.
Mm-hmm. And Tuka, how about IBC? Don't you believe that this could be, let's say, the final product of all producers? Because now, let's say, they are turning into TOPCon, and in order to reach, let's say, the highest efficiencies, of course, even the tier 1 manufacturers have it on their roadmap somewhere in 5 years that they will have 25% powerful IBC cells on the market. So do you see IBC also go to utility scale in future?
It's impossible to guess. Of course, it's possible if the production cost is in line with other technologies. Of course, then it will go to utility scale products as well. And the scale needs to be demonstrated, and the cost needs to be demonstrated in big enough scale. But in end of the day, utility will choose what is the best, what produces the best equation, best results in a financial equation. And at this moment, it is impossible to guess what it will be in the near future.
Mm-hmm. Okay, thank you. Now talking about tandems, the future technology. In your perspective, I'm asking now everyone, maybe not Carsten, but maybe Carsten, you have also your opinion on tandems. Do you think that we will see tandem technology out there in the next coming 5 years to maybe, of course, not come to utility scale, but do you have it on your R&D roadmap, and how far do you think we are already with tandem technologies? I think, Christian, you are cooperating with the TNO also on this topic, and just give your statement what you think will be the future.
So it's a technology guess. I think we are not only cooperating with the TNO, but also with ESA and other institutes here in Europe. That's what I like, cooperating with this. And for sure, the progress was really incredible for the last years. And I believe personally that we will see it. I don't know if this will be the utility scale market in the beginning, or is it some special niche market in the beginning. It depends a little bit on how really the small scale results can be transferred to big site production. Yeah? And that is, I think, the missing link at the moment. And for sure, we are working especially on this link, because from the lab results, you could produce it by tomorrow, but not for a full production site.
So maybe, Firas, do you have some plans also going, let's say, tandem in future? Are you following this topic, or is it first N-type and then maybe tandem in future?
Mainly, our focus is on N-type for the subcell, of course, but we are also in some collaboration with some site groups, both in Turkey and Europe. But our position for now is on the subcell.
Okay, thank you. And Tuka, what do you think? Is an IBC cell a good substrate, a good bottom cell for tandem technologies?
Yes, of course it is. However, I don't know if it makes if it's any better than the others. The tandem technology has been moving very, very fast, and the trick is that will it solve all the remaining hurdles, or will it get stuck in one of them? I wish I knew the answer.
Very good.
Yes,
so,
it is definitely in our roadmap.
Okay, like 3-terminal and 4-terminal, maybe 2-terminal. Yes. Difficult. Okay. Yes, I think it's time also to turn to the audience, and also for the poll, because at the opening of new PVSEC, we had a poll on what the audience believes will be the solar cell production capacity in Europe in 2025. So can you please display the poll once again? And so the question is, PV is coming home. What do you think will be the solar cell production capacity in EU in 2025? Is it 0 to 1 gigawatt? So at the moment we have about 600-700 megawatts. So we have below 1 giga solar cell production. So do you believe it's 0 to 1 or 2 to 5, 6 to 20 or 21 to 50 gigawatt? And yes, we will see the answer, I think, in 2 or 3 minutes. Maybe I give the question also to you. What do you think will be the case in 2025? I think, Christian, you have to say more than 3 because these are your plans.
Yeah. Okay. If I remember the plus and minus, yeah, then I should announce that it hopefully will be, let's say, between 10 and 20. Yeah.
Okay, so you also believe in REC that there are 2 giga expansion plans, and
to be honest, I don't think about unique companies, but I really believe in this market, and I am believing in this market for many years. So Rado, you know when I started, and so this market will be there. So I think that's where we are sitting all in one boat, even if we are competing for the companies from time to time. But at the end, the solar energy is a very important market to fight the climate change. And there will be this market, and I think there's no doubt that there will be also production here.
Mm-hmm.
And whether it's a new company or an old company or whatever, yeah, the most important thing that there are companies.
Mm-hmm. What do you believe, Tuka, Firat, Carsten?
I believe that there will be PV production, cell production in range of 5 gigawatts. But I believe that this it's just a really starting point of a flood of new investment in this field.
Mm-hmm. Do you have an opinion? Mm-hmm.
I think we might be closer to 20 gigawatts, but it always takes longer than you think to get started. So capacity and output may be also different things. I think it'll grow quickly during that period of time.
Okay.
I can tell for now we already have 1 gigawatt for Turkey, but I know there are plans for some 2 or 3 more companies for cell production, because there are some incentives for local production from the Turkish government, energy ministry. So the capacity, I think it will be more than 5 gigawatts.
Okay. So do we have, very good. Wow. So it's a very interesting curve. So zero believes that it will stay as it is. Good. Some believe it will be between 2 and 5. So let's say 2 big players, but most of them are saying 6 to 20 gigawatt. And yes, hopefully this will grow in future, that in 2020, that in 2030, we will have something like 30, 40 gigawatts, because we will enter then the terawatt market. And I don't just see that China can produce 1 terawatt of all the value chain. And this would be a very unhealthy situation. So I believe we have to, let's say, produce at least 7 to 10% of the global market, and more or less produce what we would need in Europe ourselves.
And if we talk about producing what we need ourselves, it's not necessarily, we are of course not a closed economy, so it's not that we keep everything we produce internal. There will be trade, and what we produce we export as well, and we will also import. So it's an international business. But at the same time, there is the capability and increased resilience that we need to have sufficient production capacity.
Okay. Any other comment from you on this chart? I think that this is quite positive. Okay, so let us turn now.
Is my vote counted?
I don't know. Did you vote?
Yes, I know. I said 6 to 20.
Okay. Yeah, so this will, let's say, be an improvement of this curve. So no, we don't count your vote. Good. So let us turn now to the questions from the audience. And there is one question why we are talking always about Europe and not about the MENA states, for example. It's a EU PVSEC, so we like to, let's say, elaborate what will happen in Europe. But maybe a question to you also, and to Christian, mainly I would say, why not to produce solar cells in MENA state, because there's a lot of money for installation of new PV systems, but the question is this a good environment for producing ingots, cells, and modules in the Middle East?
So I would say why not, and I think Firat gives a good example what you can do. Yeah, really to if you're encouraged enough and you can do something like in Ankara, that's great. And I think why we are not looking for this at the moment is because we are not localized at the moment. So this is something where you have to have localized people which know how the structures work, how the politicians are working, how the funding is working. And this is just another project, and we are focusing now on this European business, but I think it's worth to look at. And yeah, why not in general?
Mm-hmm. Tuka, I think, yeah, sorry.
Yeah, we are looking at different opportunities in this region. It is as discussed a very much contact-based market, so you need to have the correct contacts. So it's not just a general subsidy available for everyone, but you need to meet the criteria there. So yes, it is an interesting market. We are looking there for the different opportunities.
Mm-hmm.
I think for ingot and wafer production, we are looking for especially electricity supply, and that's something that we are very well served in Norway with hydropower. So that's certainly an advantage there. In terms of cheap and green electricity, that is not readily available, not yet, maybe in MENA states. But if there's more solar and cheap solar, then that may change the equation a little bit. Cooling water is still an issue that clearly is much easier in Norway than it is there.
Yes, and Carsten, will you concentrate on producing wafers for Europe, or are you also, let's say, having plans to, let's say, supply wafers to US and other countries?
We are supplying internationally. That's what we do today. And so principally, there's no particular region that we are supplying to, but it makes it, of course, easier. And we like the concept of local value chains. So it reduces transport costs, it reduces working capital requirements, and collaboration becomes easier, etc., etc. So there are many advantages in that sense, but it's not limited.
Mm-hmm. Okay, we have now one question here from Monica. I think we discussed this question already, but I give you still opportunity to answer it if you have some other ideas to what we discussed here before. So the question is, the end market was subsidized for PV modules during a long time in Europe, and that's why during the time many PV manufacturers in Europe closed down. And now we have a new chance. So the question is, how do we want to sustain the European R&D in Europe or local production? And I think that's a general question that we already discussed before, but I think Monica is also asking what political measures have to be taken to let's say, maintain the solar cell production that we will certainly build up in Europe. So Carsten, do you have any other things to tell Monica to make her more optimistic?
Yeah, I mentioned earlier the environmental policies, for example, eco-design, to support the advantages that we have in Europe, but also on we mentioned the financial side earlier. For example, loan guarantees to support and de-risk the financing. That's would also help. and building the whole value chain. So with scale, so it's critical mass. And to attract also the supply industry and to build the whole value chain, including glass, including all the different consumable suppliers, and that requires enough scale, of course, and ultimately also equipment suppliers, and they need to see, of course, growth and growth in the future, so that they can sell more equipment, and so that's all part of a common vision that we have, and build the industry around that to make it work.
Okay, maybe you mentioned the machine manufacturers, and Christian used to work a long time for Rena. So do you see that it's possible that Rena will stay in business, because of course the equipment is copied in China, but let's say the quality of the wet chemical equipment is still better. So will the production in Europe, will it be able to use European equipment, or will that be also possible that we see in future solar cell producers using Chinese equipment?
Okay, so even though I'm not maybe can officially speak for the European equipment suppliers, but for sure what we have seen is, as soon as you have a value proposition, as soon as you have something, then you can sell it. And for sure also the salaries in China are increasing, production costs in China are increasing. So I'm totally convinced that Europe still has a right to play it. We have extremely good and well-experienced suppliers here. And if all these suppliers are doing their homeworks well, then for sure they can supply all time to every market. But for sure, I read one statistic in China. They have so many engineers every year from their universities as all the engineers we have in Europe altogether. So this is just a competitive market, and we have to focus on our strengths, and also we have to work hard and not maybe always talk, but more do.
Okay.
This is especially my hint to these politicians, yeah. So we can have political rounds all over, but at the end, someone just should open the money valve, and that's it. Yeah, the money is printed anyhow, and let's give it to companies like Valoa, etc. Yeah, let's try it, and it's always good invested.
Mm-hmm. And so, if ICO will produce in Europe with European equipment.
Yeah, for sure. But for sure, let's say, why is Meyer Burger maybe not an equipment manufacturer anymore? Because maybe the machines were just too expensive. And I think it's, as always, it's a lot. Everyone can understand that also an equipment supplier has to survive. This means there has to be some profit margin. But if the profit margin is more than 100%, for sure, then it will be interested to maybe look deeper in it. Maybe you can copy it or whatever. Yeah, but for sure, it's the value proposition as well. Then it will be bought also from China, and it's not only ICO. Also, all these other companies are still purchasing European equipment as soon as it is worth to buy.
Tuka, expansion with European or Chinese equipment if you are going to 1 giga maybe in future?
I would be hard to discount Chinese equipment completely. They have developed, but in the end of the day, it is the value proposition as discussed. The machines are only a rather small part of the machine investment. Is rather small part of the overall investment and overall profit and loss in this investment. So it's really more on what the machines can do, how the processes work, than the actual price. So so if Chinese equipment are equal or better than our European machines, then it's very hard to justify the higher price and slower, longer lead times and slower clock speed than the Chinese competitors.
Mm-hmm. So we can ask Firat how much, if you can disclose how much European equipment is in your PERC production. What's the percentage?
I can disclose. I think for cell line is a mixed production facility. So wet benches are European G1 production, but the rest is Chinese for the first phase. But for the second phase, we are having our high temperature equipment for cell production from European suppliers, so there will be a good benchmark in the production lines. For ingots and module lines, they are mainly based on Chinese.
Mm-hmm. Carsten, and I guess the pullers will be then a Chinese product.
Yeah, in our segment, unfortunately, there's very little left that is not Chinese. So I'm afraid, yes, there is the equipment that we buy is primarily Chinese. But of course, again, that's where the market is. That's where the big expansions are. So in that sense, it's not surprising. But on the other hand, one also has to see that with that increasing experience, it's also not necessarily the case that although it's cheap, it's not necessarily poor quality. Some of it is, but there is also good quality coming out of that.
Mm-hmm. Yes. Okay, so let's check if there is another questions from the audience. I don't see any. So thank you very much for your participation. For me, it was very interesting to see, let's say, also the other side of the medal, like PERC and IBC, and PV's coming home. And it's also good to see that the audience is quite optimistic that we will grow a couple of gigawatts until 2025, whether it's Greenland or REC or ICO, maybe also Valoesel expanding to gigawatt scale, even if TUCA does not want to. Let's see what will happen in future. And so thank you very much for listening, and see you next time.
Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you very
And
much.
regards.
Bye-bye.